A sample of 125 is drawn from a population with a proportion equal to 0.56. Complete the parts 8 through C below. And so I've copied it over here so we can look at it. Determine the probability of observing, and I forgot to put, the first one is 68 or fewer successes. Well, it's going to be the same process that we've been doing, but we have an extra step. First, we have to get the proportion. So here, I'm going to move this down out of my way. So 68 or fewer successes. Well, we have to get our proportion. We need a fraction. So 68 successes, x is equal to 68, and our sample is 125. So 68 divided by 125 will be our proportion. And that is 0.544. And let me see if we have to round. I don't think we do. It says to 4 decimal places is needed. Okay, yeah. So we're good because this came out as 3. All right, once you get your proportion, you're ready to calculate your standard error of your proportion, which is P, and that is given to us 0.56 times 1 minus 0.56 over divided by n, which is 125. So we're going to do the standard error is equal to the square root of 0.56 times 0.44 divided by 125. So let's just put that in. The square root of 0.56 times 0.44. And we're going to divide that. We want to multiply that. I'm just going to put an extra parenthesis. I really don't think I need that. It should multiply and then divide. But divide by 125. And so our square root looks like it's going to be 0.0444. So our standard error of our proportion is 0.044. Now that we have gotten our standard error of our proportion, we are ready to calculate our z-score. So let me copy that formula over so we can look at it. So step 1 was to calculate the proportion. Step 2 was to calculate the standard error of the proportion. Now we have to do the z-score for the proportion. And it is equal to the sample proportion minus the proportion. And then the denominator here is the standard error of the proportion, which we calculated to be 0.0444. So your z for your proportion, your z-score for your sample proportion is going to equal negative 0.36. And I really think that this is a mistake in this formula. I really think there's supposed to be a line above the P for the sample proportion to show that it is the z-score for the sample proportion. Okay, maybe not. It's just the z-score for the proportion, so you don't have to have that line above it. Not that that's a big deal, but for me it is. Okay, so negative 0.36, we're looking for observing 68 or fewer, so it is going to be cumulative. And we're doing this the same way that we've been doing this part. Oh, we're using the table though. So we need to look this up on the table. Negative 0.36 would be 0, 1, 2, 3, 4, 5, 6 would be 0.3594. Okay? Now, what would you do here for 72 or fewer? You would do the same thing that you just did, but your proportion is going to be 72 divided by 125. So this number up here would change, which would change everything else. But I want to look at, I'm going to skip B because you would work it similar to what we did in A. And I want to go to C, determine observing 62 or more successes. So first we need to calculate our proportion for our sample, which is X, and X here is 62. Of course, N was given to us. Our sample was 125. So 62 divided by 125. So that would be 0.496. Now we need to calculate our standard error of our proportion. So you take the population proportion, which is up here, 0.56, and times that by 1 minus 0.56 over N, which is 125. And I should have left that alone because that is going to be the same. And I can't remember what it was now. .0444, and I remember us doing that in Excel. So I didn't really have to rework that. I shouldn't have erased that part. That only is going to change if the sample size changed. Okay, so now we're ready to get the z-score, and we're going to do our sample proportion, which we calculated, 0.496, minus P, which is the population proportion, divided by the standard error of the proportion, which is 0.0444. So 0.496 minus 0.56 divided by 0.0444 is going to give us a z-score of negative 1.44. We need to look that up on our table, and we're looking at the negative 1.44, so let's find that. 0, 1, 2, 3, 4 would be 0.0749. So we need to do 1 minus because this is, we want to know greater than, so we have to use the complement rule. Okay, so 1 minus 0.0749, and that would give us 0.925. 0.9251. So let's look at that. Let's look at our answer here. 0.9251 would be correct. Okay, so let me know if you have any questions. Remember, it's the steps of, you're going to calculate your proportion, your sample proportion, calculate your standard error of the proportion, and then get your z-score for the proportion, and then you either look it up on the table or use Excel. Let me know if you have any questions.